Today, I'm not gonna talk again about Hugging Face and collaborative AI, but you get the point. I showed you the tasks page yesterday. As a reminder, it's always helpful to begin with this because you can figure out what you can do with AI. So a lot of potential ideas, and each time when you dig into the page, you have a tutorial in video, but also some code snippets that will really help you to get you started. Today, we're going to explore how to find the best models on the hub, because there are many different models. So, and the question I have often is like, what's the best model? It's really hard to say because it really depends on your needs. But let's say you want to do, for example, an image classification tool. So you can here filter by the task, and here you have the models. So as you can see, for example, the #1 trending model right now is a model from Google, but you can also like filter by most likes or most downloads. So here you can see that this model has been downloaded 31 million times, so it can be useful. And if you click on it, you have everything you need to deploy it with an API if you want to prototype. So this one is free, so you don't need any credit card or something like that to test it. And you can also sometimes run it locally. You can test it directly in your browser. So for example, in my example yesterday, we will see how it will classify this image. So we can wait a little bit. So you see here a soccer ball, a jersey, etc. The main difference with the no-code solutions that I presented yesterday is that here with the API and pipelines, you're going to be able to run tasks on many files. So let's say text, images, PDF, etc. So it's a more like a automated way to help you leverage AI with this. Same with the data sets. You have a lot of different filters, like formats, extra. So if you are looking for different data sets, let's say, I don't know, do we have? Yes. So we have here, for example, no, we didn't know Shipstead has an organization page, which is fun. So you can see they have a data set with SEO headlines and text. So it could be quite useful if you want to fine tune a model in this language, obviously. But yeah, it could be fun. And we'll see after that how to use these data sets and models in a pipeline. It's also important to evaluate the models. And you have two ways, basically, of evaluating the quality of a model. The first one is the benchmarks. So we run different series of tests, mathematical tests, question and answers, etc. So for example, here, you will find the OpenLLM leaderboard. Unfortunately, it's only for open source models because it needs to be replicable and transparent. But you will see here, for example, the best performing models on different benchmarks, such as MMLU Pro, for example, which is a well-known benchmark on questions and answers. And you will see also the CO2 cost. So it's a useful way to know if your model is environmental friendly or not. So a good data point for you also. So just an overview of how to select a model, but then your question might be, how do I run the models, or how do I use the data sets? We're going to see this with this collab notebook, which is a notebook I built especially for journalism use cases. So if you're not that into coding, it's not that hard. It's just like, you will need to understand the logic of it. So you're going to connect to the GPU that is on the Google servers. You will load the libraries from Hugging Face that will allow you to deal with models and data sets, or transformers and data sets. And the Q and the U is just like to remove some messages that are annoying for me. So we will wait a little bit. And then, for example, here for the task of captioning images. So let's say you have a whole set of images and you want to caption them so you can search and sift through the data. Or, for example, if you need help as a helper for your CMS, you can call the model and have some basic captioning, and then you can improve it. So you can publish your story with a caption. So what we will do is import the pipeline. Basically, the pipeline is a way to make your life easier. It loads a lot of different tasks, such as embedding and that kind of things. And we will call the pipeline image to text. It will take an image, generate a text from it, and we will take this model that we previously selected on the hub. And if I go back to my tasks page, I guess image classification, here, image to text. And here you can see this model is like the model by default because it's a very obvious and a very good one. So the models will be loaded into your Collab notebook. And by the way, if you run this notebook locally on your computer, it will be secure and private. So no need to send information to an outside server. And here I'm going to import just an image, but you could load a folder of images. So with the URL, and we're going to wait a little bit. It's going to load the image and generate a caption. So you can see here, it's very basic. It needs to be improved in that case because this model is it has some guardrails, so it won't identify people, but you can find models that are able to recognize politicians, for example, or that kind of thing. You can also run some classification. So for example, for comments, we will run the pipeline text classification. And here you have 3 different comments. This restaurant is awesome. I never eat here again. Disgusting. Do they know how to cook? And so here you can see the labels that are attached to each comment. So the first one is obviously positive, and the 2 others are considered negative comments. It's what we call the zero-shot classification, but you could also give some pre-decided labels to your model so it can act upon it. And you have a score, so a confidence score, which is useful if you want to establish a threshold, for example. So it could be quite good. Here, another classification model where we will have, as you can see today, we're introducing the Greenhouse Gas Pollution Pricing Act. So it's a sentence. Let's say you want to classify a lot of different law bills. So you can create your own labels. So politics, environment, and decoration. And it will try to classify it. So as you can see, the highest ranking is for environment, but also politic. And it correctly recognized that it was not about decoration. NER is a name entity recognition. It's also quite useful for investigations, for example. So it can extract every entity in a text. So for example, names, institutions, locations, that kind of thing. So I copy pasted the text from the New York Times, and we will run this model. So again, you have the pipeline with the task, which is called NER, the model that I choose. And you can really reuse this Collab notebook from out of the box. You can tweak it if you want to select different models. But as you can see here in this long text, it has extracted correctly Biden, Senate, Republicans, etc. And you can also tweak it a little bit. So for example, if you already logged Biden, the model could avoid repeating twice or the number of times the word appears in the text. We also have pipelines for object detections. So I don't remember. I don't know if you remember the examples I gave yesterday, but you can train a model to recognize or identify a specific object in a wide set of images. So here we will run the model with several examples or labels that we want to identify. So woman, flag, curtain. And we will see what will happen. And while I'm waiting, I see some questions. So for Geoff, the link to the collab notebook is in the presentation. So here, you just click on it and you will have access to it. And the models is really like when you go to the homepage of Hugging Face. So for example, here for models, let's say we're running an object detection task. So in computer vision, I will select object detection and I can see several models. I can, for example, filter by, most downloads or that kind of thing. A useful thing also is this small lightning. It means that it's served warm in the inference API, so you can call it with the free API without having to load anything. So it's quite convenient. And so we're going to see our test. It finished? Not yet. We just loaded the models. Gianluca, you asked a question about the handwritten letter for printed text. This is a good example. So it was with a Qwen 72VL, I think. So you could load the model in a collab notebook and have it running or identifying the text in your how to say it, in your notebook. So here you can see in our image, it has correctly identified with the flag we gave it. So a woman, a flag, and it didn't show any curtain, but there isn't any, so you can see. But you can imagine a whole wide array of possibilities depending on your use cases and your needs. For transcription, yesterday I showed you the web GPU example, so it runs in your browser, but you need to upload a file after another one. Here, you can just run the pipeline. I won't do it because it would take a little bit of time, but you get the idea. So you load the libraries, then the model. Here I have the tiny model in English, but I think we could run, I didn't test it, but we could run the Whisper Large V3 Turbo model that I showed you yesterday, which is the most efficient one, I think. And you can load your files. So it's just one file here, but if you have a folder with many, many files, you just write the path to the folder and it will load every file and transcribe them. So we load the automatic speech recognition pipeline. Then so we load the model. And so for example, here I have a dream speech and you can see the example. So even though we face the difficulties of today and tomorrow, I still have a dream, etc. And so as you can see, it's also time-stamped, which is quite useful. So you have either like the whole chunk of transcription, but also the timestamped one, which is useful for many different use cases. And here, another example, which is very interesting, it's a translation. So we are using small models from Meta called No Language Left Behind. So it's a model that is open source, and that was trained on many underrepresented languages. And it's quite small. It's only 600 million parameters, which means that you can fine tune it if you have additional data in your language. And so, for example, if I want to translate from French to Haitian Creole, salut, ça va? Well, the answer would be, we wait a little bit, but I think it's, well, no, my Creole is not good enough, so I'm not gonna try it. But you get the idea. So the pipeline is really easy. It makes your life easier to use a wide array of tasks and a wide array of models. So this is a basic notebook, but it's a good start if you want to explore like different tasks, different models. It's really up to you afterwards. Let's wait for the result, maybe. And once the model is loaded, it's really faster because it just processes the data. So bonjour, ou pas travail, web travail. Other examples, a really important one, I think, because open source models shine when you fine tune them with your data. But fine tuning is could be a little bit scary. You're like, oh, how do I do this? It's not that hard, honestly, especially with this tool called AutoTrain. So AutoTrain basically can help you with different tasks. So for example, LLM fine-tuning, which is very useful. But for example, here, summarization. So let's say you have 100 articles you wrote and 100 summaries for each of this article. It will be, let's say, a spreadsheet, so a CSV file. If you want to fine-tune a model on this summarization, you just create your tool. So it's quite easy. You give it a name, blah, blah, blah. You duplicate the space. And then, what did I do? Oh, sorry. Test LSR. So we give it a name. And then it will create the space. And what it will ask you is a well-structured data set, so or text and or summaries, and to choose a model. So let's say you want to fine-tune Llama 3.2 with 8 billion parameters, which is a small but efficient model. So you will have the dropdown, and then you will import your data, and you will just specify the name of the columns, and the tool will take care of what we call the hyperparameters. And so it will fine-tune the model, and then the model will be served on the hub, and then you can use it for your use case. I'll come back to this later on to see where it goes. And if you want to do it the hard way, there is this library which is really efficient. It's called the transformer reinforcement learning. So you can fine-tune your model. So for example, for sentiment tuning or detoxifying some LLMs, it could be like really useful. And let's see where we're at. Let's come back later for the sake of the presentation. And another example, if you want to train an image generation model, you can do it. So it's based on AutoTrain and Flux. Flux is a very efficient model. You can train it with a very tiny data set, meaning if you have only 10 pictures of a person, for example, you can train the model to be able to generate images from this set of examples with the specific keywords that you can call to the model. If you want to spin up a demo, either for your team, so let's say you want to work on a specific model with several use cases, or for your audience, there is this very powerful tool called Radio. And so, for example, here, let's say I want to draw, oops, you get the idea of like a person. Well, it's a microphone. My drawing is terrible, but I need to be better at it. But you get the basic. So you can create a demo quite easily. If you go to spaces, you create a new space here. You give it a name. So call it test. And here in the radio, you will select a template. So let's say you want to build a chatbot for your audience with a specific data set or something like that. So you're going to select the chatbot template. I'm going to make it private, just like for us. And okay, cool. Coming back to auto train. As you can see, again, up, right. Sorry. So here is the window for auto train. Seems complicated, but it's not. You just select a model and you upload your training data. So I don't have any training data on hand, but it's quite easy. And you map the text. So it's the name of the column. And here is the like pre-filled, so pre-optimized. You start the training and you're good to go, which is let me come back to the space. Cool. So my chatbot is up and running. It's a basic example, but as you can see, it's already here. And if you click here, you can see the files. So everything was generated for you. And in the app.python file, you can see that by default, the model that was called here is a Zephyr 7 billion parameters beta, but you can call your own models. So let's say you built an image classifier or something like that. You can input an image, input an audio file, a video file, and the model will run with the tasks you will ask to do. So it took 2 minutes, and you can spin up a demo for either public or your newsroom. I'm really showing this to you like at full speed, but if you need some help using either Hugging Face or Gradio, you have a chatbot based on our documentation. So for example, let's see, for image classification, I don't know what will be the answer, but hopefully it will be interesting. So it's calling the tool. And as you can see here, it's already generating some function. I can also ask it, we have the same for Gradio here. So how do I start a chatbot Gradio app? And sometimes it will even generate the code, or you can ask it to generate the code for you. So it search through the documentation, and it will give you hopefully an interesting. So as you can see here, it wrote the code for you. So yeah, quite helpful. Something I also want to note is that you can have access to free GPUs in the spaces. So the example I showed you, for example, for the chatbot. So if your model need to call, because we have CPUs and GPUs, GPUs are a lot more for heavier needs. You can just specify what we call the decorator in your code, and it will call the free GPU inference on your space. It's a more advanced function, but useful for maybe for people in the room. Another notebook I built, and it's an example, but if you have some interesting data and you want to create a chatbot or an agent to help you. So for example, here, I built a data set with the electoral, the presidential results dating from 1976 to not the last election, but the previous one. So you have in every state the number of votes, the number of electoral college votes, etc. And so what I built is a notebook where you have a RAG agent. So it will have a certain capacity of, I don't like that word, but reasoning. It will be able to perform some queries for you, but also find the best method to do it. So I'll connect and load everything. Oops. All right, so yeah, not sure we'll have the time to wait for the answer because it will load a lot of libraries, but as you can see, it calls the data set and it will recreate a database with your data set. And there is some prompting here that I did. So I just explained the data set basically to the tool. And I call my agent. And for example, I call here a model, but you can choose your model here. For that kind of reasoning tasks, you will need a more advanced model. So here I'm calling Quen 2.5 with 72 billion parameters. And so if I ask what's the total number of votes cast in 2016, it will perform a search and retrieve the information. But don't wait for anything because it will take too long, but you can explore the Collab notebook. You really have all the info for you. If you want to analyze some data sets on the hub without downloading them. So for example, here I have prompt for ChatGPT, and I want to find the prompts related to travel, let's say. So what the model will do, it will, you talk to the machine with your words, and it will translate it to a SQL query. So it will query the database. And so as you can see, it found every prompt in the dataset that was related to travel. So it's just a basic example, but there are, I think, 500,000 data sets on the hub. So it's quite useful for like basic exploration to know if it fits your needs or not. If you want to analyze some tweets, so it's, but let's say yesterday, I think I talked about this investigation by the New York Times about the post of Donald Trump on Truth Social. It would be the same approach. For that, you don't need a big foundational model. It's a basic task in AI. You can use BERT topic, for example. So the Collab notebook here will guide you through everything you need to do. So you have your data set here, which are like the tweets. And you will the model, run the analysis. So it will automatically classify the topics of the tweets without any input from you. So it's really like a deep learning task. And you can also create some interactive visualization of this and topics over time. So for example, here, you will see that, a run for president or Carolina border wall was important, maybe in 2019, etc. So just a basic approach, but very versatile. If you want to also implement a RAG tool for your newsroom, we have some documentation and Collab notebook. So here, an advanced RAG with a length chain. So this library is well known for augmented retrieval generation. So you will have all the basics. Again, sorry, I don't have the time to run through all the sheet, but you have the agentic one. And let me show you this, which is a visual RAG. So it's trained on a new approach, which is called Polis. So it's multimodal. So you can ingest images, PDF, text, a whole array of different files. And compared to a standard retrieval architecture, it will be way easier. So for example, here, the traditional approach of OCR something, and it's related to the question that someone asked previously for handwriting recognition. Previously, it took 7 seconds per page, and we were able to break it down to 0.4 seconds per page. So it's way more efficient, especially if you have a ton of data to analyze. It's done with a small model. So it's a 7 billion parameter model, kind of medium model, if you want. So you can install the libs. And for example, we have this PDF here. So it's with a lot of images, it's not text. So it's harder to retrieve the information from it. But as you can see, we will index the PDF and we will ask a question. For example, how much did the world temperature change so far? And so it will retrieve on page 6, and it will give you the information. The Earth's average global temperature has increased by around 1.1 degrees in 19th century, blah, blah, blah. And so this is the correct answer. It was able to retrieve info from a PDF or from an image. And again, you can ingest like thousands of pages in this method. So quite useful for multimodal RAG, which is a trend we see developing, and it's quite useful in journalism. This example is a little bit more technical. So if you're interested in, I just dive into the notebook, but it's to generate a data set based on, let's say you have headlines from your articles generated by human. You have your article and you want to generate a different headline by an AI model following specific rules. So for example, under 60 characters, that kind of things. And after that, you can call another LLM to evaluate which of the headline is the best regarding your rules. And so it will like improve the quality of your data set. And you can also annotate the data set after that if you want to fine tune it more and more and more. This is also very interesting. I don't know if you remember the missing in Chicago example yesterday, but they trained a model on annotations with the community of readers to train a model and then ingest many, many different files. This is the kind of tool that could be helpful for this. So it's called Argia, and I give you an example here. We're running a sprint of image comparison. So to rank the best model, the best image generation model. So for example, here, the prompt is to create a neon punk portrait of a prehistoric man, blah, blah, blah. So do you find that the first image is the best or the second one, or they are both good or both bad? You can choose here. And so at the end, when you run through all the tasks, it can be done collaboratively in your newsroom or with your community. You will have a data set with the annotated preferences. And so you can fine tune a model with much more efficiency than without annotation, because in fact, we focus a lot on models, but I would say at the end of the day, the quality of the data is probably more important than the quality of the models. So very, very interesting and very easy to deploy. Argia is like deployed in several clicks. I'm gonna skip this example, and yes, that's it. Sorry for the speed of this presentation, but I have a hard stop. Feel free to reach out if you have any questions. But I really encourage you to explore the notebooks, the examples, and I don't know if do we have time for 1 or 2 questions, or you want to?
Yes, you can ask any questions. Okay.
Yeah. So let me sift through the questions. So your question is very interesting. maybe you could dig into yesterday's presentation because it was focused on no-code solutions. So it's really like the easiest way to advocate for AI solutions because it's easy to use and you can get a good grasp of the capabilities of it without having to open some code. So the command line wall is important, and yeah, it's a good concern. Is there something that can answer what's going on here? I query regarding thousands of documents once. So relationships between companies, property, people, transactions. Yes, absolutely. Well, the example I have in mind is what we call a knowledge graph. So it's a type of RAG. We have some documentation on the hub for this. It's really, really powerful because you can ingest a lot of documents and it will automatically like establish connections between either people, institutions, that kind of thing. So, and you can chat with it. There is also a local solution for this. What is it called? I think it's called Quatin. Yes. So it's an open source RAG tool that you can download on your computer, and it will download mobile on your computer. So you can cut off your internet connection if you want. And you can ingest many documents, and it will create, as you can see, this graph here, and you can interact with your data, and it will give you the sources each time. So it's a very, very powerful tool and really, really fun to use. And the collab notebooks, they are not on the website, but they are in the link of the presentation. And so, and the link for the yesterday presentation, well, I'll let the organizers do it if you need the presentation. Again, sorry for being such in a rush, but thank you for attending this, and thank you, Polis for the invitation. It was a pleasure to be here today.